Hi there. We have a really special guest today. Ryan Garrett is going to tell us about the Mono Lake story. And he's just been down at a conference in South America. I don't know exactly which country, um, where they were talking about phalaropes and other sorts of things. And he'll tell us about that a little bit later after he tells you about all the other things he does that are wonderful. So this is Ryan Garrett.
Awesome. Well, good evening, everybody. Thank you, Jeanette, so much, and League of Women Voters so much for having me today. I'm excited to talk to you all about Mono Lake, the Mono Lake story, and how Mono Lake, this salt lake in California, led me all the way down to Argentina and everything in between. So, kind of with that said, I will start sharing my screen here. 2 seconds. That, and then let me present. So, once again, my name is Ryan. I'm the education director for the Mono Lake Committee, and today I will be telling you all the Mono Lake story. So, I always start off every presentation with where Mono Lake even is. I grew up in the Central Valley of California, and most of my life, and it wasn't until I was 19 years old that I knew where Mono Lake was or what Mono Lake was. And so there's Mono Lake. It's this little blue dot near the California-Nevada border. And that little blue dot on that map is actually quite large. Mono Lake covers about 70 square miles and it can fit two San Franciscos in it. So it's quite massive when you're here. And extends its mountain ranges, which we'll talk about later. The mountain ranges that bordered in actually extend into Nevada. And then, sorry, I lost my cursor. In Mono Lake, that blue dot is estimated to be about 1 to 3 million years old. It's believed to be the oldest salt lake in North America. And as a salt lake, it has some unique waters. So Mono Lake is set in a basin, which means it's surrounded by four distinct mountain ranges. So to the south, it is surrounded by the Mono craters, which are considered the youngest mountain range in North America. They're believed to be about 40,000 years old. So you have the youngest mountain range next to the oldest salt lake in North America, right in the same spot. To the east, you have the Caltrack Mountains, and these mountains help divide the state of California and Nevada, I mentioned earlier. To the north, you have the Bodie Hills, which is home to the ghost town of Bodie. And then to the west, you have the iconic Sierra Nevada. And as we know, during the winter months, the Sierra Nevada gets covered in snow. And come spring, like right now, that snow starts to melt, and that water will make its way into one of these five creeks feeding into Mono Lake. So in the north, we have Mill Creek, and it goes Levining Creek, it goes actually Walker Creek, then Parker Creek, and then Rush Creek here. And so these are the five tributary streams that feed Mono Lake. And as you can see, the water flows into Mono Lake, but it has nowhere to go. Mono Lake is considered a terminal lake. And as a result, the only way water can leave Mono Lake is through evaporation. And so as the water evaporates out of Mono Lake, what it leaves behind is salt and minerals. So while we consider the water flowing off the Sierra Nevada fresh, it does contain trace amounts of salt. And so over the last 10 to 15,000 years, that salt has built up and built up and built up and built up. And it's made Mono Lake a salt lake 2.5 times saltier than the ocean. What's really interesting about these chemicals and these minerals going in here is it's not only salt, but calcium and carbonate also mix in Mono Lake, and that forms these tufa towers. Mono Lake is known for these tufa towers, these rock structures. And so calcium and carbonate will mix underneath the surface of Mono Lake. They'll combine to form a rock that we all know called sandstone. That sandstone will clump together and form these towers that you see. And then after years of diversions, which we'll talk about in a bit, these towers now stand outside of the water. So that's Mono Lake's sort of water, its unique water chemistry. And because of the unique water, it has a unique life system within it. And there are only three things that can live within the brine that is Mono Lake. The first is algae. Mono Lake has plenty and plenty of algae from decaying life. And one of those decaying lives and living lives are brine shrimp. So Mono Lake is home to a special species of brine shrimp called Artemia monica. And so these brine shrimp can only live in the brine that is Mono Lake. And these brine shrimp have a unique life cycle. So we have the male here with these large pincers, the female here with this really large tail. And what happens is during the warm summer months, these brine shrimp, they will reproduce and give live birth. Those live births will molt about 11 times into their adult forms, and they'll repeat that cycle. But then as the waters get colder around September and October, it triggers in the brine shrimp that they need to not give live birth anymore, and instead they will lay eggs. They will lay these partially developed embryos as known as cysts. These cysts will sink to the bottom of Mono Lake where they'll hang out dormant all winter long. And then as the lake heats back up come May, these eggs will hatch into these babies, once again, molt about 11 times, and then turn into these adults, and then they will repeat that life cycle. So they give both live birth and lay eggs. They have a bimordial form of reproduction. And these brine shrimp, like I said, called Artemia monica, can only live in the brine that is Mono Lake. If you were to take them out of the solution and put them in your tap water or put them in Great Salt Lake or put them in the Salton Sea or something, they would die. So these brine shrimp are found only at Mono Lake. And then the other thing that lives in the waters at Mono Lake, which aren't unique to Mono Lake, but are unique to a lot of salt lakes, are brine flies or alkali flies. And so these alkali flies, if you come to Mono Lake, you will see them on the shores of Mono Lake in their adult forms. But these adult forms, or as adults, they only live for about a week of their life outside of water. The majority of their life they spend underneath the water at Mono Lake. So these adults, they will feed on algae on the shores of Mono Lake. They will breed. The female will lay an egg. That egg will sink to the bottom of Mono Lake. It will hatch into a larva. It will feed on algae. And then, much like a caterpillar will, it'll attach itself to a rock. In this example, we have a tufa rock, where it will form a crystallized structure around itself. And then it'll hang out in this pupa stage for about 2 weeks, and then it'll hatch into its adult form. So it spends about 1 week here and 3 weeks underwater. So these three things here are the only things that can live in Mono Lake, and both the brine shrimp and the brine flies feed on algae. And these three guys here form the basis of a very important food web at Mono Lake. So at Mono Lake, what Mono Lake is very well known for is its bird populations. And so millions of birds, which we'll talk about next, come to Mono Lake and feed on the brine flies and the brine shrimp, and whether it be for nesting or migration. So they will come and they will feed on this buffet of brine flies and brine shrimp. I also didn't mention how many brine shrimp are found in Mono Lake. It's believed that about 4 to 6 trillion brine shrimp are found in Mono Lake. So it really is a buffet for the birds and the animals that eat these brine shrimp. So the birds will come, and then mammals will typically eat those. And then also for time immemorial, the Kuzetica, they are the indigenous people of the Mono Basin. They also would eat the California gull eggs and the fly pupa. And so this is what the fly pupa look like here, and what the Kuzetica would do. The Kuzetica is they would wade into the waters at Mono Lake. They would find a tufa rock that had a bunch of fly pupa on it. They would get their hands, like this person's doing here. They would run their hands along the tufa rock, dislodge all this pupa, put it into these woven baskets, let that dry for about a day, peel off the exoskeleton, and be left with this grain of fly. They would eat it as you would a cereal. It was considered a delicacy, and it was actually their main trade stock. What's really interesting about the Kuzetica, once again, they're the first people of the Mono Basin, and what they called the fly pupa and the flies is kutsave, and themselves Kutzetica, that same root, kuts means fly. And so Kutzetica, what that roughly translates to, are the people who eat flies, or the fly people eaters is the direct translation. And so the flies are the namesake for the first people of the Mono Basin who still live here and speak for the land today. So this food web is important locally for a variety of reasons, for a variety of creatures, but it also is internationally important for a bunch of migratory birds. So Mono Lake is a part of the Pacific Flyway. And so we'll kind of communicate this point through this guy here. This is called the Wilson Phalarope, and this is a female. She will make an appearance later on in the presentation. But the Phalarope, they will start their journey in Canada, or they will breed in Canada and they will raise their chicks. But as we know, Canada can get quite cold, and so they don't want to hang out there. And they actually want to get as far south as South America. They make a 5,000-mile migration every single year, but they can't fly from Canada to South America and Argentina in one shot. They can't do it. So what they need to do is they want to get down to Laguna Marchiquita in Argentina because it's nice down there. It's warm down there. They can drink mojitos down there. Anyway, so they want to get down there, but they can't in one flight. So instead, they need to fly to Mono Lake. They go to Mono Lake and they use Mono Lake as a gas station. They fuel up and they eat brine flies and they molt into new feathers, more than double their weight, and then they fly from Mono Lake down to Laguna Marchiquita, a 3,000-mile migration from there. And so Mono Lake is internationally important for millions of migratory birds. The Wilson's phalarope isn't the only bird that does this, and millions of birds every year flock to Mono Lake because of that brine shrimp and that brine fly buffet that I was talking about. And there are 4 bird species that in particular that rely on Mono Lake for their survival. So if Mono Lake were to go, these bird species would be critically threatened. The first is the Wilson's phalarope, the one I just talked about here. The next one is a cousin of the Wilson's phalarope, that is the redneck phalarope. So the redneck phalarope, it too will start its journey in Canada. It will then fly down to Mono Lake. It too will double its weight. It will feed on the brine flies, the alkali flies. And then from there, it will head into the Pacific Ocean where it will winter. But it needs to come to Mono Lake, fuel up, molt into new feathers, and then head out to the ocean. So it's a critical stopover site for them. The other bird that uses Mono Lake as a critical stopover site is the eared grebe. Once again, this bird also starts its journey in Canada. And then about 1 million eared grebes come to Mono Lake every single year. They will feed on the brine shrimp. They will more than double their weight and actually get so heavy that they can't fly right away. They have to starve themselves for a week and practice flying to get off the surface of the water. So they will fly from Mono Lake down to Baja, Mexico, where they will winter. But once again, they can't get from Canada to Baja, Mexico in one flight. They have to stop somewhere. They've chosen Mono Lake as their stop site. And the last bird that relies on Mono Lake for the survival of its species, you all in the Bay Area are more than familiar with, and that is the California gull. So the California gull will hang out on the coast during the winter months, but then come summer, it will actually fly inland to Mono Lake, where it will nest at Mono Lake. It will raise its young at Mono Lake. And for a very, very long time, Mono Lake was the second largest breeding ground for California gulls. The first largest was Great Salt Lake in the state of Utah. And funny enough, the state bird of Utah is actually the California gull. So that's a fun fact for the day. But these 4 birds, they rely on Mono Lake for their survival. If Mono Lake were to collapse, these bird species were threatened, and that almost happened. So down south, there's a little city called Los Angeles, and Los Angeles in the late 1800s, early 1900s was experiencing a massive population boom. The railways in the east finally connected west, and Los Angeles was being advertised as this tropical oasis. So people began moving there, and the Los Angeles Department of Water and Power quickly realized that the Los Angeles River watershed alone would not sustain this boom. That river alone wouldn't sustain the boom and wouldn't sustain all the people that were coming, starting farms, all the people moving and living there. And so the Los Angeles Department of Water and Power quickly realized in the early 1900s that they needed to find an external supply of water to provide its people. In search of this water, they first came up to the Sierra Nevada and they found Owens Lake. So there is Mono Lake right there. And then Owens Lake is about 150 miles south of Mono Lake, and it too is a salt lake. It had its own unique brine shrimp and supported millions of birds as well for hundreds and thousands of years. But because it was a salt lake, salt lakes in the late 1800s, early 1900s were considered useless. They were considered a waste of fresh, clean drinking water. You couldn't fish in them. It was painful to swim in them. They smelled bad. And so, because of that, Los Angeles Department of Water and Power said, let's practice water conservation and divert all the fresh water that flows into Owens Lake south. And that's what they did. So they built an aqueduct, the Los Angeles Aqueduct, and through a series of canals, underground tunnels, and a lot of dynamite and manpower. The Los Angeles Department of Water and Power built the Los Angeles Aqueduct, and it started to divert water out of Owens Lake in 1913. By 1926, just 13 years later, Owens Lake completely dried up. This is typically what Owens Lake looks like today. Last winter, we had an insanely wet winter, and Owens Lake actually filled up. And so there's a thin layer of water of Owens Lake over Owens Lake right now, which is really exciting to see. But unless things change, that water will dry up, and Owens Lake will look like this again. So with this new supply of water, the city of Los Angeles continued to grow. And they said, we need to extend the aqueduct. We need more water. And they found Mono Lake. Once again, Mono Lake was a salt lake. They said this is a perfect blueprint of what's going on at Owens Lake. We're wasting fresh, clean drinking water here. So in 1941, they extended the aqueduct and began diverting streams that normally feed Mono Lake. They diverted Levining Creek, Walker Creek, Parker Creek, and Rush Creek starting in 1941. They actually had plans to extend to Mill Creek and bought land and water rights up here, but they never extended it that far. And so beginning in 1941, water did not flow down into Mono Lake or below the diversion points. As a result, the streams and the trout populations in the Mono Basin completely dried up and died. And Mono Lake dropped over 45 vertical feet and doubled in salinity. This had negative consequences on the food web here. If you increase the salt content in Mono Lake, the algae are going to go down. The brine shrimp are going to be stressed out finding food. The brine flies are also going to be stressed out finding food, and they will stop reproducing. That means California gulls no longer have food. Mammals and people at that time also wouldn't have food, and the ecosystem here would collapse. If the ecosystem locally collapsed, that means the phalarope and millions of migratory birds also cannot make their migrations. And so having the ecosystem collapse here was going to have massive consequences all around, not only locally for the people that lived here and the animals that lived here year round, but internationally for the millions of migratory birds that migrate to Mono Lake. So what was there to be done about this? So in 1978, the Mono Lake Committee was founded to address this issue. It was founded by this man here. His name was David Gaines. David Gaines in the 1970s with a couple of friends came out here and they studied Mono Lake as a part of the first ecological study of Mono Lake. And he was a grad student at Stanford. The rest of the crew were college students at UC Davis, and they got an undergraduate research grant from the National Science Foundation to study the impacts diversions were having at Mono Lake. Through that study, they realized the dire situation that Mono Lake was in, and he fell in love with the lake and wanted to advocate for it. So through this new committee, he started the political campaign to save Mono Lake. And in 1979, the Mono Lake community sued the Los Angeles Department of Water and Power under the public trust doctrine. And what the public trust doctrine states is that there are certain ecosystems that are so valuable that their longevity and integrity need to be ensured before anything domestic can be done to them. So before the Los Angeles Department of Water and Power can just divert as much water as it wants, it has to ensure that the ecosystem that is Mono Lake and the streams that feed Mono Lake need to be protected and need to have standing and need to be healthy for generations. So in 1983, the courts ruled in favor of the Mono Lake Committee, and Friends of the Earth and the National Audubon Society were also involved in that court case. But this didn't do anything right away. It wasn't until about 11 years later that Decision 1631, D1631, was issued by the State Water Board, and it was determined that Mono Lake needed to rise 20 vertical feet and that the streams needed to be restored. So the restoration progress for Mono Lake began in 1994. And so Mono Lake at its historic low was here at 6,372 feet above sea level. Its pre-diversion high was at 6,417 feet above sea level. So once again, it dropped 45 vertical feet. It was determined after the lawsuits and according to Decision 1631 that it needed to increase 20 vertical feet to 6,392 feet because that was considered the healthy ecological level. And so Mono Lake, and this is an important point, will always remain artificially low. We'll never restore it back to the 6,417 feet above sea level. Where we're trying to get it to is the 6,392 feet above sea level, which was once again considered to be the healthy management level of Mono Lake. So by the year 2014, the lake was supposed to rise this 20 vertical feet to 6,392 feet. Did it? Well, Mono Lake today. So water is flowing through the creeks again, which is beautiful. The Los Angeles Department of Water and Power is taking far less water than it did prior to Decision 1631. But Mono Lake, while it's risen, is not at the healthy management level. It's not at 6,392. Today, it's about 6,383 feet above sea level, so it's about 9 feet short of its healthy management level. So I'm going to get into why in a second and sort of what happened, but I figured right now would be a good kind of pause point, a little intermission. So I'll stop my share for a second and kind of ask questions before I get into kind of what's happening today and what happened between 1994 to today. Does anybody have any questions about sort of the natural and political history of Mono Lake, about the birds, about the alkali flies, the brine shrimp, about it becoming a salt lake, things like that before I continue?
I think I have
I think Emily is trying to talk. Jeanette.
what?
I think Emily is trying to talk. Emily, are you trying to talk?
I
No.
don't know.
Okay, I thought I saw her mouth move. Okay, go ahead, Jeanette.
I was just going to say I've spent a lot of time out around Mono Lake, so I think I know most of those things that you were saying, but I wouldn't be able to remember them quickly. So, but I appreciate your presentation.
Of course, yeah.
Brian, I had a question for you about the groundwater. So
Mhm.
do you happen to know what the groundwater levels were, how they correspond when the lake goes up and down? And how far does the groundwater basin extend out from there?
Yeah, that's a great question. I'm not sure of like the exact amount, but the groundwater is heavily impacted. So there was a bunch of wetlands that surround Mono Lake that are fed, were fed by that groundwater. And as the lake started to decrease and less water started to go in Mono Lake, all of that groundwater also went with it. And we're going to talk about groundwater a little bit later and how a lot of the groundwater is actually being diverted through the Los Angeles Aqueduct. The Los Angeles Aqueduct, as a benefit of being built underground in the Mono Basin, actually takes about 11,000 acre feet of water. So that water is being taken from the Mono Basin, and that water would normally saturate the ground. And there's a bunch of freshwater springs that are normally around Mono Lake. Those have dried up. They're since recovering in some really intense wet years. Wetland habitat is trying to recover, but unless there's a big saturation of groundwater, that's also not going to happen. So,
Okay. I suppose most of the snow in the mountains uh, feeds in through those creeks, the 5 creeks that you identified. Is there much snow that falls on Mono Lake in the winter? Directly on
it
the lake?
does. Yeah, it does, but you never know like how much because Mono Lake doesn't freeze. It's not like, Gull Lake, which is just a little south of us, and June Lake, that freezes over. It's a fresh lake and you can kind of see the feet of snow accumulate. But because Mono Lake is a salt lake, it doesn't freeze. Snow certainly falls on it, but we never know how much snow is actually getting into the lake. It's actually funny. We had this really intense blizzard at the end of February and really high winds, a bunch of snow, and nobody knows where that snow went. It like was coming down. It was coming down sideways. But like the next day when everybody came out, we were like, where's the snow? We were all like, it just had to end up in the lake. It had to have gone in the lake. There's no other explanation that the snow just like went into the lake and it vanished. But anyway, but yeah, it's a good question. We're not sure how much snow actually gets in there, at least directly. Like I think we can measure before and after we took a daily measurement to see how much was in there, but it does fall on the lake and it pretty much immediately turns into water.
Okay, you don't have any idea how deep the snow piles up on the banks of or the shoreline of the lake?
Right now, none, but last winter, at least I want to say we had about 10 feet at one point in the basin. So
Okay.
it can get really high, but last winter was an exceptional year. But I mean, enough to cover sagebrush, and so people could cross country ski all the way to the shores of Mono Lake. So a significant amount.
So there was also enough that it was difficult to drive on the highway.
Correct. Yeah, you couldn't drive on the highway and you couldn't drive on the dirt roads to get down to the lakeshore. You had to actually, our team that measures the surface of the lake, they had to cross country ski every month to get down to our lake level gauge where they normally could just take a road down there and drive their car. So, yeah.
That would be quite an extended cold snap to freeze the lake over. So
Maybe,
that
yeah,
might
like
that
a
might
thin freshwater layer.
that
Yeah,
might
that would be
rival
cool.
the North Pole or the Antarctic temperatures. 50
Yeah,
below, 100 below.
yeah, that might do it. That might do it. Well, great. So, oh, sorry, Ruby, go ahead.
You're muted, Ruby. You have to turn your mute off. Ruby, you're muted. Sorry, Ruby, you're muted.
Sorry, Ruby, you were muted during that question.
You still are.
Looks like it's still muted, Ruby. What I'll do, if it's okay with you, is
Okay,
there you go.
okay, there. Is there any idea, probably not, but is there any idea how evolution resulted in these very, it's almost unimaginable how evolution resulted in the failure ropes, or how these pathways evolved so that these bird populations would survive.
Yeah,
I
I'm
mean,
not sure. Oh, sorry.
okay.
I was just gonna say I am not sure, but my partner, who is much smarter than me and is a bird researcher, is trying to figure that out because in theory, salt lakes are incredibly taxing on a bird. You have to constantly be filtering salt. It's another stress response. It's something that a bird like if you wanted to be a very efficient bird or a very efficient animal, you want to be filtering salt constantly through your system. So why are there all these salt lake bird specialists that love salt and need salt to survive? It's like such a fascinating question, and I'm not sure. And I will come back to you all in maybe 7 years when my partner has finished her PhD and has answered that for me. And so alrighty, so I will pick back up then with what has happened between decision 1631 and 1994 to today. So I'll jump back into the presentation. Let me share my screen. So let me get in present mode. Oh, it jumped me right to the back. Did not want that. Here we go. Okay, no. Okay, sorry about that. I don't know why I'm getting all the way to the back. I will quickly speed through this. Apologies. Almost there. Okay, there we go. So when decision 1631 happened, it was sort of twofold in the way the plan was laid out. It said you need to restore the streams and you need to restore the lake. And so we'll take those in turn. We'll first talk about the stream restoration, and then talk about the lake trying to reach the management level and why that hasn't happened. So the streams in decision 1631. So the judge said the following quote, which I think is really important to orient us in the discussion of how these streams are supposed to be restored. So Judge Finney was his name. He said the license, so the Los Angeles Department of Water Power's new license, shall release sufficient water into the streams from its dams to reestablish and maintain the fisheries which existed in them prior to its diversion of water. So what Judge Finney said is that the streams need to be restored prior to the condition prior to the diversion of water in light of fish. So they need to be restored, and they need to be restored for the fish populations. And so there are two fish that Judge Finney had in mind. The first is the brown trout, and the other is the rainbow trout. And so the streams need to be restored in such a way that was conducive and supportive of brown and rainbow trout populations. Once again, when the streams dried up below the dams, these fish died off. These fish died off below the dams. They were there upstream, but there was estimated to be about 40 to 50,000 trout below the diversion points. And when the diversions happened, creeks dried up, these fish also died. And so now the plan is to restore the streams so these fish are happy and healthy below the dams again. And so that's kind of a tall ask, because due to extensive desiccation, wildfire, and grazing, the streams were destroyed. So what you're looking at right here, this was Levining Creek prior to decision 1631. So this was it prior to 1994. And this just gray, sandy, rocky area here, that was the old creek bed. And there are no trees around it. You wouldn't know this was a stream. Trout love trees, but because of droughts, the trees died up. They were snags for a while, and then a really intense wildfire happened, I believe in the 80s, that burned down all the trees that were standing there. So those trees left. And then there was sheep grazing for a long time in the Mono Basin. So any vegetation that would begin to grow along these stream banks would be quickly eaten up by sheep. And so it prevented these streams from being restored. And then what also would happen in wet years is that there'd be so much water that the Los Angeles Department of Water and Power couldn't take it all. And so as an emergency situation, they would just send that water down these dry stream beds. And what would happen is that these artificial channels would be cut. So if we look here, you can see just this channel off the main chute of the stream being cut. And this is an artificial stream being cut by extreme wet conditions and wet years with a dry stream bed that couldn't control the flow of water. And so this posed a serious challenge for the stream scientists and the group that wanted to restore these streams. And they equated discovering where the streams used to go, their old channels, where trees used to go, where pools used to go for trout. They equated it to an archaeological dig. So much damage had been done that they actually had to bring excavators into these stream beds, pull up soil to try and find bedrock and gravel again to figure out where the stream bed naturally would go. And they were quite successful in this. So prior to decision 1631, this is what Levining Creek used to look like. And then post decision 1631, this was 6 years later, this is what Levining Creek looked like. So a significant recovery. And once again, this is prior to decision 1631, and this was 6 years after decision 1631. So water had flowed back into these streams. The streams were becoming much more vibrant. Things were looking good. But remember, these streams need to be restored back to the pre-diversion levels where they can sustain a trout population of 40 to 50,000 trout. And so a study was done in 2010, and stream scientists recommended changes to the restoration agreement. They said, look, this is great. This is a really good start, but this is nowhere near the levels that they should be. And so what they recommended that the Los Angeles Department of Water and Power adopt was this thing called stream ecosystem flows. So the Los Angeles Department of Water and Power, when they would decide to divert water, they kind of did it when it was convenient for them, not in relation to the natural cycle of water runoff or anything like that. So what would happen sometimes is during peak runoff events, when a bunch of water would be flowing off the Sierra Nevada that would normally go down these creeks, flood plains, move cobblestones, fall trees that would create these natural pools, those benefits of the peak flow events would be missed downstream of the diversion sites because the Los Angeles Department of Water and Power would divert the thrust of those peak runoff events down to Los Angeles. And so what they recommended is said, hey, Los Angeles Department of Water and Power, how about you time when you divert the water, so that way you can kind of create this natural cycle again, or try and appeal to a natural cycle of water running off the Sierra Nevada. So that kind of agreement came out in 2013. And in 2021, another long name, Order WR 2021-0086 was issued, and that amended the original restoration agreement, which allowed for the stream ecosystem flows to happen down Levining Creek. So once again, this is post decision 1631. And then this is what Levining Creek looks like today. So a significant change. Once again, they had some time for some more trees to go, but because of this floodplain that happened, there are trees growing now in the stage area. This other natural channel, not an artificial channel, this other natural channel now has water flowing through it. It has trees growing in it. Beavers have also inhabited this area and are falling trees naturally, which create pools for trout, which is great for trout. So Order WR 2021-0086 was great, and it's been a huge benefit to Levining Creek, but it didn't only benefit Levining Creek, it also benefited the other creeks as well. So as a quick refresher, Mill Creek was the only creek not diverted by the Los Angeles Department of Water and Power. So that water would flow down into Mono Lake, but the Los Angeles Department of Water and Power set up diversion points at Levining Creek, Walker Creek, Parker Creek, and Rush Creek. But what this new order did is it said no longer will the Los Angeles Department of Water and Power take water from Parker Creek and Walker Creek. So now, forever, starting in 2021, now until, once again, for the future, water will no longer be diverted from Parker and Walker Creek. So those streams, to the best of their abilities, there's some old dam infrastructure still there, are returning back to their natural conditions. Levining Creek, it was ordered stream ecosystem flows would happen through there. It was also ordered that stream ecosystem flows needed to happen at Rush Creek. Big issue, though, with Rush Creek is that water does not naturally flow into Rush Creek. So this is the Grant Lake Reservoir. So this is where the Los Angeles Department of Water and Power stores all the water before it goes down to the city of Los Angeles. So all the water gets diverted through tunnels all the way into here. Rush Creek starts in these mountains here, flows into Grant Lake, and then this was a natural situation and a dam wasn't here, it would flow from Grant Lake. You imagine the spillway wasn't here, it would flow down here, and then that would be the natural sort of topography of the creek. The issue is that when the Los Angeles Department of Water and Power built the Grant Reservoir, that the only way for water, or one of the main ways for water to get back into Rush Creek, was through an artificial canal. So for water to get from Grant Lake down to Rush Creek, it had to go through this canal that would connect right up here and down into Rush Creek and then build and go down. The issue is if you have a canal allowing and controlling the water flowing into a creek, you cannot get peak runoff events. That canal will always constrict the flow and only let a certain amount of water down. And so Rush Creek can't benefit from stream ecosystem flows and peak runoff events. So under this new order, it said what has to happen is that the Grant Dam needs to be modified. This spillway here, which is normally only used during wet years. Basically, if the water gets so high in the Grant Reservoir, then the water will spill down here as an emergency procedure. What's going to happen is that this spillway is going to be lower, and this will be the control valve that will allow peak runoff events flowing from Grant Reservoir down into Rush Creek, so Rush Creek can experience the benefits as stream ecosystem flows and peak runoff events. The issue that we ran into as of last year, though, is that the Grant Reservoir and the Grant Dam partially failed. So what has to happen now before this construction process can begin is that the Los Angeles Department of Water and Power has to fix the dam, which is like a 3-year process, 2 to 3 year process first, according to the Division of Dam Safety, before the spillway project can be worked on. So at minimum, we're looking at least 7 more years before the Grant Reservoir gets modified to allow stream ecosystem flows down into Rush Creek. So that's kind of what has happened from 1994 to today with respect to the restoration of the streams at Mono Lake. And the streams have come a really, really long way. The streams at Mono Lake were kind of the main focus when Decision 1631 happened. The solution to raising Mono Lake, people thought, was just add water. If you add water to Mono Lake will reach the management level. The streams, however, required a little bit more active management. They were damaged extensively, and so people put all their eggs kind of in the stream basket and focused on restoring the streams and thought the lake would just kind of naturally follow. That didn't happen. And so, as we mentioned, in 1994, it was determined that the lake needed to rise 20 vertical feet to the healthy management level, which is this medium blue line here. 2014, lake's not there. It's at 6,383 feet. So it's come up from its historic low about 11 feet, but it's still 9 feet shy of the management level. And what happened? What was the plan that was put into place that was supposed to raise the lake? Well, the plan was actually quite simple. So the plan was, it was this diversion plan. And so the diversion plan said, if the lake is below 6,377 feet, the Los Angeles Department of Water and Power cannot divert any water down to LA. So if the lake was low, considered low, which is what we consider the 6,377 feet, the Los Angeles Department of Water cannot divert any water. All the runoff from the Sierra Nevada gets to go and gets to raise Mono Lake. The lake is between 6,377 feet and 6,380 feet. The Los Angeles Department of Water and Power can take up to 4,500 acre-feet of water. That's, compared to what they used to do, that's a tiny amount, but it's still significant. And so it was kind of like seen as this is sort of this, like, you can take some, but you can't take the full amount. The full amount that they can take is that the lake is between 6,380 feet and 6,391 feet. The Los Angeles Department of Water and Power can take up to 16,000 acre-feet of water. So this was the plan. These were the rules that were put in place. It's kind of 3 simple rules here. And it was thought that if we follow this according to the models, then Mono Lake would rise to the healthy management level within about 20 years. But that didn't happen. This is what happened. So this is our rainbow graph. That's what we call it here at the Mono Lake Committee. And so there's a lot going on here. Here's what the lake used to be at prior to diversions. This was the lake at its low at 6,372 feet. And then this blue hue here, this whole section, this marks when Decision 1631 happened. And as you can see, Decision 1631, the lake was below 6,377 feet. So the Los Angeles Department of Water and Power couldn't take any water, and it experienced this massive spike in its lake level over a series of 4 years. So actually 4 years of above average winters. And so the lake went up, and then it stalled there, and then it started to go down, and then it went up, stalled there, and then went down, went up, down, up, up, down, up to where we're at today. And so what we've seen is this waffling. And so that what we've realized was that the diversion criteria that was set forward in 1994 is not going to get Mono Lake to the management level. The thing is, what happened? Why does this original plan not work? And so there are a few reasons. First is that the hydrologic predictions were off. So when all these hydrologists got together to model the rise of Mono Lake, they based it off this series of years here. So from 1990 to 1940, and what these pink lines represent are drought years. And so as you can see, from 1990 to 1940, there were only 2 periods of drought. From 1990 to this graph shows 2022, there have been 1, 2, 3, 4 periods of drought. So they made their model off a series of wet years, and what came out of the future was a series of dry years. And so the model that was used was just off. It used a series of wet years to predict the rise of Mono Lake, and it didn't reflect the dry years that were to come. The next thing is that it was assumed that the city of Los Angeles, as it grew, was going to need more water. Predictably, as the city was going to naturally grow, the city of Los Angeles would still need water from the Mono Basin. Amazingly, what has happened is as the city of Los Angeles has grown, it is using less water today than it did in 1994 due to low flow toilets being kind of the primary thing, fixing leaky faucets, and a huge campaign by the Los Angeles Department of Water and Power. They are using less water today than they did in 1994. So that prediction was off. And then finally, and we were talking about this briefly earlier, there's an unregulated amount of water that the Los Angeles Department of Water and Power will always get. The Los Angeles Aqueduct, that section that is built in the Mono Basin, is built underground. And as a result, about 11,000 acre-feet of water get into the Los Angeles Aqueduct that would normally feed down into Mono Lake. And there's no regulation of that. We can't tell them to not take that water. We can't do anything to control that water. That's just an added benefit of the Los Angeles Aqueduct building that infrastructure. And so as a result of all this, the Los Angeles Department of Water and Power diversion since 1994 has resulted in Mono Lake being 5 feet shorter than it could be today. So right now it's at 6,383 feet above sea level. If the Los Angeles Department of Water and Power paused diversions in 1994, it would be at 6,388 feet above sea level. And at the end of this year, at the end of this runoff year, would be about 6,390 feet above sea level, about 2 feet short of the management level. So because of those diversions, it's added up to be about 5 feet shorter than what the lake could be today. So the consequences of the lake not reaching the management level are pretty bad. The first are dust storms. So the Mono Basin, as a result of Mono Lake, is considered the worst place in the country for PM10 air quality violations. PM10, that's particulate matter that's about the size of a strand of hair. And if you breathe that in, it will cause respiratory problems short-term and long-term. And so because of the lake being at an artificially low level, the salt flats are exposed, and during windstorms that happen in the Mono Basin, those salts get kicked up in the air, and it creates this terrible air quality problem. So that's one, dust storms. The other is threats to California gulls. So as I mentioned earlier, Mono Lake for a long time was the second largest California gull nesting sites. The California gulls used to nest on Nedget Island, but what happened is during the at its lowest point, this land bridge right here, which in this photo, there's a little bit of water showing, but during the lowest level at 6,372 feet above sea level, this island, Nedget Island, was landlocked. And it allowed coyotes to get onto the California gull nesting sites and eat their chicks and eat their young. California gulls are incredibly smart birds. They live for quite a long time. And so they have now decided to nest on these islets of Twain and Java. But what happens is that, we've submerged the land bridge, at least a large portion of it, with Decision 1631. But when the lake gets around 6,378 feet above sea level, the California gull populations are threatened again. This water channel here is only about 3 feet deep, and this is not a very far swim for a coyote. And what happened in 2016 is that a coyote got on this land bridge and swam across here to Nedget Island, walked across, got into Java Islet, where about 5,000 California gulls were nesting, and ate all of the chicks. The California gulls no longer nest there. They have not returned to nest at Java Islet, and now they're all nesting on Twain Islet. And so when the lake is at the 6,378 feet above sea level, which it was in 2022, the California gulls are threatened. And this was a photo in 2022 of a coyote scouring that land bridge looking for California gulls and ways to get out to the islets. So with the lake being artificially low, we have air quality problems, we have dust storms. The California gull nesting colony is threatened. And then also what happens is, according to the Clean Water Act, Mono Lake has to stay at a certain salt level. It can't be too high in its salt concentration, because if it does, the ecosystem is unhealthy. Once again, at this lake level of 6,378 feet above sea level, which it was at just 2 years ago, the salt levels exceeded the Clean Water Act, and the ecosystem was deemed to be unhealthier than it should be. So there are some serious consequences with the lake being at this artificially low level for so long. We're a decade removed from the decision, and the lake is not near the management level. Are we doomed? We are not doomed. So according to decision 1631, it states that parties can come together to renegotiate a new agreement. And that's where we're at today. We didn't really push for this renegotiation right away, because like I said, when decision 1631 came out in 1994, everybody was focused on the streams. We had a good working relationship with the Los Angeles Department of Water and Power, and we wanted to work together on restoring the streams and focusing on the streams. The streams were an issue, the lake's an issue. We have sort of almost just about solved the stream issue, and so now we can begin focusing our attention on the lake issue. And what's really, really exciting is that the State Water Board elevated the Mono Lake issue into its 2024 priority work plan. So at some point this year, we're not sure when, we're still eagerly awaiting the State Water Board to let us know, we will have another hearing about the Mono Lake issue. It will start the next big conversation, debate, fight to save Mono Lake and develop new criterias and develop new rules to restore Mono Lake back to the healthy management level. And that's where we're at today. We're really excited about that. We sent a letter to the mayor of Los Angeles, asking for them to not increase diversions this year, letting them know about the State Water Board hearing, and all of us here at Mono Lake are getting ready for this big hearing, because like I said, it signals the next big fight to save Mono Lake and restore Mono Lake back to the healthy management level that was promised 30 years ago. So I will pause again here for a brief intermission before I go into the little bonus round about what I was doing down in Argentina and how Mono Lake is connected to all these great sister lakes. But I'll pause here for any questions, because that kind of got us to today with the Mono Lake story. We started out with the natural and political history, and now we're to present day. So I'll pause again for any quick questions. Or long questions, that's fine too. Great. Well, if we don't have any, I will just jump along. Oh, Michael, you trying to?
You gotta,
Oh, looks like you're muted.
you gotta unmute.
Is that it?
Yes.
Perfect.
Yeah. Has the State Water Board talked much about the public trust and the role of the public trust doctrine in the new hearing?
It's a great question. I'm sure it's going to get brought up, but I know what the public trust is certainly going to get mentioned. I shouldn't say that it's not going to. It's definitely going to be heavily talked about and referenced, because it was this promise that was made in 1983 to restore Mono Lake to the management level. Like, the public trust set the groundwork for the decision in 1994. What I imagine what they're going to do, and what they've done in previous preliminary, I shouldn't call it a preliminary hearing, but we had an emergency hearing in 2022 about the local lake level. What the State Water Board heavily emphasized was decision 1631, because in decision 1631, it's really easy to point to and say, look, this is where the lake level is supposed to be in Los Angeles Department of Water and Power. You haven't gotten it there yet. And so it's easier to point to an agreement that they voluntarily agreed into and say this is the level it's supposed to be at. Where the public trust, once again, it set the groundwork for that, but we're more like we're on like the next phase of getting to the actual nitty gritty of numbers, and I imagine that's where the conversation is going to head towards.
And they think that numbers thing can be talked about independent of the California Public Trust doctrine?
Well, certainly it can. It can. I mean, like I said, the public trust doctrine in 1983. In 1983, it was determined that Mono Lake was considered a public trust value, and that the lake needed to be restored, and the values there need to be protected. But it didn't set like the concrete numbers and restoration agreement numbers, like where the lake should be, how the stream should be restored. It didn't set that in the original in 1983 agreement. It was in 1994 with that secondary agreement that those numbers came out. And so it's like one and the same, and the public trust is what got us here. But
yeah,
it's
but
that
the state of my question is the state of California acknowledging that California has a public trust?
Yeah, I think so. I think they're definitely going to do that. I think I think they're going like that's a commitment that always gets referenced in any of these discussions, that the public trust and the values at Mono Lake need to be protected, and that's why we're trying to get the lake back up to a healthy management level.
And the Mono Lake Committee will actually talk about public trust?
Yeah, absolutely. Yeah.
Good.
I mean, in every blog post, newsletter, article, I'm sure we mention it at least 4 or 5 times.
Great.
Great. Okay. Well, that's a good segue into the public trust, because we'll talk about that shortly. This was kind of, Jeanette asked today if I could talk a little bit about my time down in Argentina. And I thought in order to do that, I need to kind of take a step back. And why was I in Argentina? Why is Mono Lake part of this like global network? And so we're going to go back to our Wilson's Phalarope. And as I mentioned earlier, Mono Lake is part of the Pacific Flyway. And so this bird, the phalarope, it breeds in this pink area here in Canada, and then it will fly down to Mono Lake where it will stage. But Mono Lake isn't the only lake that it stages at. It also stages at Great Salt Lake. And so Mono Lake is considered a sister lake with Great Salt Lake. And then from here, with Great Salt Lake and Mono Lake, the Wilson's Phalarope will want to head 3,000 miles south to Laguna Marchiquita. And what we have realized is that the Wilson's Phalarope has shown us that Mono Lake, Great Salt Lake, and Laguna Marchiquita are all sister lakes. And we can't just focus on saving one site independent of the other two. Rather, the health and knowledge of Mono Lake, and the health and knowledge of Great Salt Lake, and the health and knowledge of Laguna Marchiquita in Argentina are all tied together. And that we need to move from saving, or I shouldn't say we should move, but in addition to saving ecosystems locally and thinking about issues locally, we also need to develop a global saline ethic. So once again, part of the Pacific Flyway, Mono Lake is a sister lake with Great Salt Lake and Laguna Marchiquita. And where we're at today, one of the political missions of the Mono Lake Committee is conserving saline lakes globally. And so we have developed this international network between us, folks at Great Salt Lake and Laguna Marchiquita, and we come together and how do we conserve these saline lakes? And we do it through a variety of means, but 3 which I'll highlight here. The first is obviously sharing knowledge. So every year, the Great Salt Lake has an issues forum, and the Mono Lake Committee, we always go there and present and share what's going on at Mono Lake. We hear about what's going on at Great Salt Lake and see how we can help each other and just stay abreast as to the issues that are going on. And the other thing that happened at the end of 2022 is down in Laguna Marchiquita, it was designated as a national park. The Mono Lake Committee was invited to come and talk about the history of Mono Lake and also share our knowledge of our legal fights to protect Mono Lake, because Laguna Marchiquita, as is with so many other salt lakes globally, water diversions are such a negative impact on their long-term health. And one of the things that's coming out of this was sharing knowledge at Great Salt Lake. and Laguna Marchiquita, as we were just talking about, Michael, is that Great Salt Lake is using the public trust doctrine. In 2023, the fall of 2023, a group is suing the state of Utah under the public trust doctrine. And so obviously in support of this, and Mono Lake, and what happened here is a good blueprint for legal proceedings. And obviously the situation is a bit different there in Utah, but this is kind of a result of the sharing of knowledge, continuing talking between all these partners, is that a group in Utah said, hey, the public trust doctrine works so well at Mono Lake, let's try and use it here in Utah. And so that kicked off in 2023. So sharing knowledge is one of the ways we conserve our lakes. We obviously clearly unite on causes, and this kind of gets me to where I was at. So we have our mural again here. So this past February, myself and a few folks from Mono Lake went down to Laguna Marchiquita for the second ever International Phalarope Working Group meeting. So the International Phalarope Working Group meeting is an international group dedicated to the protection and conservation of phalaropes. And so what we have here is a group of researchers, site managers, conservationists, and educators coming together to talk about the status of phalaropes globally from Canada, the United States, Ecuador, Bolivia, Chile, Argentina, and more, and share ideas and figure out where phalaropes are globally as a group. I was there representing the education portion, and I'll talk about that in a second. And what this kind of more immediately directly resulted in is the Save the Phalarope petition. So on March 28th, on the steps of Utah's legislative building, the Utah State Capitol, is Ryan Carl, who is from Mono Lake. He was born and raised here. He's kind of seen as like the lead phalarope conservationist. He introduced a petition to have the phalarope considered under the Endangered Species Act. The phalarope at its North American sites, it's predicted, or analysis has shown that its populations have reduced by 75%. And as saline lakes globally stay in a state of decline and peril, so does this phalarope. And so the hope is, by having the phalarope considered under the Endangered Species Act, it will provide legal protections to saline lakes around the world. So that's something we all do in our international relationship, as we unite on causes. And then the other thing that we're doing is educate youth. And so in 2021, down at Laguna Marchiquita, this group, or this education program, got started called Experience Ambientalia. And what Experience Ambientalia is a youth education program dedicated, at least in its foundation, to conserving Laguna Marchiquita. It was engaging youth in the conservation movement to conserve the lake down there. Once again, from water diversions, contamination was another big one, agriculture is another big one. And so that group got started in 2021, and their founder, her name's Marina, came up to Mono Lake last year, and we met, and she asked if we'd be willing to start an international branch to this program at Mono Lake, educating our local youth about what's going on at Mono Lake and getting them involved in environmental stewardship projects. And so over the last 8 months, that's what we've been doing. So there is Marina here, and this is her group of students. That's me and our group of students. And what we've been doing over the last 8 months is we've been doing, the word I've come on is concurrent environmental education programs. And so on the same day, so this was Coastal Cleanup Day, which I think was September 23rd, what we both did is we went with our students and we did boat tours of our respective saline lakes. And then after, we did stewardship projects. We went and cleaned up the shores of both of our lakes. And so we've been doing similar activities about once a month over the last 8 months. And what's really exciting is that this program will kind of accumulate in an international exchange this year, actually in the next couple months. So what is going to happen is we are going to mirror the migration of the phalaropes. And so what will happen in June is that Marina and her students, and this is the U.S. Ambassador to Argentina, this is Mark Stanley, he's aware of the program, which is super exciting. Her and her students will come to Mono Lake, where they will spend a week at our outdoor education center. and then participate in our bird festival, known as the Mono Basin Bird Chautauqua. So they will come in June, and they will meet their peers that have been doing the same activities over the last couple of months. Their peers have also been in touch with Zoom calls, with presentations, through text messaging, things like that. And then in July, our little local group from Mono Lake, we will head down to Laguna Marchiquita and go down there, experience their lake, get engaged with some stewardship activities down there, and connect with our peers once more. So it's really exciting. This is kind of the pilot year, at least in the United States, of this program, and it's been a really cool thing that's been happening, and it's the reason why I went down to the conference. Marina and I at Laguna Marchiquita and at the International Fowler Working Group meeting, we were talking about the successes of the program and how this is engaging local youth in conserving their saline lakes. And we hope for this program to continue for years to come. So anyway, that's all I have. I thank you all so much for letting me blabble at you for the last hour. I really, really appreciate it. And I'm here for any other questions or concerns or comments or anything like that. Once again, I just want to thank Jeanette. Thank you so much for having me here. And thank you so much for all of you coming and listening to me talk today.
Does Argentina have a public trust doctrine?
I don't know if it does. That's a great question. I should look into that. I'm not sure. I'm not sure if it does. I know that park, or at least Laguna Marchiquita, received national park standing, but that still hasn't solved the water issue there. And so the public trust could be something that could be used if they have that down there, but I'm not sure.
It's interesting because lots of countries have it in their constitutions.
Argentina is not.
Yeah, so maybe it does.
So where is this lake that you go to in Argentina?
In Argentina, it's in the Cordoba province of Argentina. It's sort of I want to say it's like West Argentina, Central West Argentina. But it's where about 60% of the Wilson's phalaropes migrate to for their wintering grounds. So it's really exciting. They'll have hundreds of thousands of Wilson's phalaropes there every year. It's also where 3 species of flamingos also winter. So when I went there, I'd never seen a flamingo before, and that was like that was definitely a highlight for that. And I think it'll be a huge highlight for our students when they get to go down there. I feel like that's one of the birds you see in a magazine growing up all the time, but you never see it in the wild, or you see it at a zoo, but you never see it in the wild. So anyway, but it was an amazing experience, and it was really good because I feel like so much of the connections that we've made in talking about Laguna Marchiquita and engaging with our partners has been over Zoom, as Jeanette, you and I were talking about, but there's something about being in person and collaborating with people in person and seeing the sites that we all care about, seeing the birds there, and it kind of really tightening that community together and making us recognize that we're all part of something much bigger than ourselves and trying to protect and conserve these saline lakes.
What is the best time to see most of the birds at Mono Lake? I know they've declined, but just a good timing. I've visited a number of times. I'm very fond of Mono Lake.
Well, that's awesome. That's awesome. I think the best time to see the phalaropes is in early to mid-July. That is the best time to see the phalaropes. Best time to see probably the biggest crop of birds. May is a good month because it's spring migration. But come end of June, beginning of July, all the birds are typically there. They kind of overlap the birds that are getting ready to migrate out, the birds that are breeding. That's kind of a good pocket of getting 2 windows at once.
Great. Thank
I think I've seen phalaropes in the bay here in our area. They look like the same ones as Mono Lake, and I think maybe they hang out with the seagulls too or something. I don't know.
Yeah. There's actually a small population of Wilson's phalaropes in the San Francisco Bay, one of the researchers that was there was actually representing the Bay Area, and there I want to say it's a little over 1,000. I think there are some pools there that are getting restored, but they've become such a critical stop for phalaropes that they're balancing the needs of restoring these pools, these tidal pools, but also making sure that they don't completely take out the habitat that these Wilson's phalaropes that have come to rely on. So he was talking about that really interesting sort of site management challenge.
Yes, I agree. Yeah, there were, looking at them there, I was like, wow, this is great.
Excellent, excellent. Well, once again, thank you all so much for having me, Jeanette. I think I'll turn it back over to you or Kandia for any closing stuff. But I just thank you all so much for being here on a Monday night. I know it's late and listening to me blabble about Mono Lake. It's my favorite thing to do.
And we didn't even have any eclipses while we were here. So did you have anything to say, Candia?
No, just thank you so much for this evening's presentation, and I can't wait to upload it to YouTube because I know some of our members are out there in Texas right now and so weren't able to join us, but we'll definitely want to see your presentation later. So hopefully you can come and see us again too. Thank you, Ryan.
So, well, thank you all so much. Thank you, thank you. I will see you all later. Enjoy the rest of your evenings, and we'll be in touch.
Yes.
Sounds good.
Awesome. Bye, everybody.